And remember, I just want symbols, please no words. I mean, if you have one or two words, I'll forgive you, but don't give me a sentence. Okay. Okay, great. And all right, when you are done with your quiz, you could take a look at Moodle, and under classwork Excel files at the very bottom, you'll find two mean hypothesis tests for today. And that's just the data that we're going to be using. When you click on that and download it, it will have, I guess I've got multiple copies now, but it will look like, once I get it, I'll show it to you. It will look like this. So it'll have some stuff. So you can do that. I'll come and get your quizzes if you're done with them, but if you're still working, don't panic. Just want to give you enough time. Nice. All right, thank you. Excellent. You're ready? I'm not rushing you, am I? All right, I'm always worried about that. When I'm wandering around, I feel like I'm making people nervous. Sometimes I want to, but look at this. We're missing two people. I already got it this morning. Yeah, I start off, my first word is always quick. I'm telling you, yeah, I always pick quick because I want to get the cue out of the way. How many guesses did you get it? I got it in 5 today. Yeah, I took 5. Oh, you did 4? Woohoo! Amazing. All right, thank you. I actually start with the same 3 words: quick, plain, and storm. Because that's 15 letters in 3 guesses. Yeah, but then you could get it in 2, and you cannot No, I get all 15 of those letters. That's 15. That's like that's more than 50% of the letters and all of the vowels. I always get it in 5 or 4. You should try sometime. Quick. No, I like to get it like as fast as Okay. Oh, do I have all the quizzes? Sorry. There's got to be something statistical about Wordle that we could discuss, but not today, apparently. Yeah, I did it. He's doing it now, and I was bragging about how I always do it in either 5 or 4 because I always have the same algorithm. I start with quick, plain, storm. Always. Doesn't matter how many letters I get right, because that's 15 letters, and then I usually can get it in guess 4 or 5. With what? Wordle? What is that? Oh, yeah, I used to do that. It's boring. Actually, that I should see if that I should see if that algorithm helps with that one as well. But yeah, we need to move on though. Enough fun and games. Although we will have some more fun and games. Yeah, this is going to annoy me. Maybe if I'll just tuck it under here. And at least I have the little puffball. I guess I'm not videotaping myself. But it seems like the YouTubers, don't they always have it on their like baseball hat? Like up here. Okay. Maybe I'll go back to the black. Okay, well anyway, yeah, let's get this quiz out of the way since I have them all now. I'm sure you all got this right. I didn't scan to see, but and by the way, if your claim is the opposite, I should have probably labeled these. You know what? On the exam, I will have you label them so that you can't just tell me this. You need to tell me that this is number one, or maybe I'll tell you which one is 1 and 2. In fact, yeah, now it's all coming back to me. On my exams, I tell you, this is sample 1, this is sample 2, because I give you the sort of the Excel output, and it's important to know which is which. So anyway, number 1 is Army, number 2 is Navy, and so this person thinks that the average weightlifter or amount of weight is going to be bigger for Army than Navy, so there you go. Opposite, then you've got this, you can sort it out, right-tailed. So if you chose to number these differently, you would have this look a little different. It would be left-tailed, but you would still be 100% correct. So this is where it's a little annoying for me when I'm grading because sometimes people switch it up, but that's okay. As long as you're consistent. For the next one, I don't know if you noticed, it's about proportions. So this is P instead of mu. If you put mu there, I'll mark it wrong, but don't worry, I won't take off that many points. But so here, let me label these two. Freshmen will be 1. So this will be sample 1, and this will be sample 2. But anyway, the freshmen, more freshmen percentage are at breakfast than seniors at breakfast. I don't know if that's true or not. I'm just throwing it out there. Opposite of the claim, and then you've got your stuff, and that's also right-tailed, unless you chose to switch these. And if the freshmen are sample 2, that's fine, because I don't show you any data here. So you could do it the opposite, and you'd still be correct. All right, very good. Let's move on. We're going to be, let's see, do I have this set up? Let's see. Yes, I do. Okay, hypothesis tests. So we're doing the 2 mean hypothesis test. Maybe I should back up and remind you of this. I know you're bored with all of these. You've seen this enough. So I'll just blow through it. We've done these 3 ad nauseum, so you're probably sick of that, and this. But now we're going to be down here in this area. Hopefully today we'll get through the means, so comparing 2 means, and then Friday we'll do comparing 2 proportions. So this is what we're really going to focus on, is computing the test statistic and the p-value, because that is what Excel has you do. I need to warn you about one thing though, and this is different than the past assignments. If you go to Newton and you look at the instruction, what they're going to tell you to do is different from what I'm going to tell you to do. Now, I just say that just so that you know that when you look at Newton, if you look at the instruction part, they're going to have something different. They are not wrong, and I'm not wrong either. I mean, I'm never wrong, but no, actually, it's not true. But I'm not wrong. They're not wrong. It's just a different way of doing it. And the reason why I do it the way I do it is because the way they do it requires you to download or at least install a plugin, which is fine. It's available for most people, but there are some people who can't get it installed and they have trouble. And I'm like, oh, I don't want you to have trouble. So if you want to go their route, that is fine. Totally fine. Nothing wrong with it. Just so you know. So we're going to do it the same way we did our last hypothesis test. And in fact, here, let's get started with this. We're comparing 2 means. And in fact, I have here, once I get my stuff going, there it is, on this spreadsheet, the one that I just asked you to download from Moodle, I have the data. This is you. This is your data. Every one of you is here somewhere, and I've randomized the order here, so you don't know who's who, but these are the exams that had the plus. This is exam 2. the exams that had the plus at the top. And if you look at exam 2, you'll see exam 2, and it either says plus or a time symbol. So the pluses, here are the times. You remember I was concerned that maybe one of these exams was harder than the other. So let's try to figure out if that's the case. So let's go back, and we need a claim. So first of all, my claim is always that the two exams are just as easy or just as hard as one another. And so here's my claim. My claim is that the average exam for plus is the same as the average exam for times. Now, I suppose I should actually say that plus is going to be sample 1 and times will be sample 2. Just for future reference, and you'll see us, when we get to doing the calculations, you'll see us actually doing, sorting them, and plus will be in column 1 and times will be in column 2. But anyway, there's my claim. I think you probably can figure out the opposite of the claim. This will inspire me to actually do, to do my attendance. Just a sec. Who is not here? Sorry, there we are. You're not here, but I think you emailed me. You're not here. Is it just those two? No one sits next to you, Hayden, do they? Not until calculus. Then you gain friends as the day goes on. Okay, good. Okay, so I think I've got the correct attendance. Yes. Okay, let me crank this in here. There, they can email me if they think that I did this wrong. Okay, random. Random. Oh, of course it's someone who's absent, but Trinity's here. Trinity, what is the opposite of this claim? Oh, I like the way you say that. Very nice. Well done. Okay, good job. And now we have to sort out the null and alternative hypotheses. So null alternative. Anna, do you know which one of those is the null hypothesis? Excellent. Everyone's pronouncing this so well. Yeah, so it's the claim. So this one here is the null hypothesis because it has the equals in it. Very good. Mu1 is equal to mu2, and mu1 is not equal to mu2. Okay, the next step is to determine alpha, I believe. Yeah, we've got, left, right, or two-tailed. I suppose we could nail that down. This is, I should have asked, too late. This is, of course, two-tailed because of the not equal to going both directions. So we'll use that in a bit. But now we need alpha. And so alpha, since it isn't given to us, let's just say that if you don't know what alpha is, just pick 5%. 5% is sort of the gold standard. It's a 1 out of 20 chance. So you're, by the way, when you set alpha to 5%, if you do 20 hypothesis tests, so if you're a scientist doing work in a lab and you do 20 tests, hypothesis tests, you should expect one of them to be wrong with an alpha level of 5%. I mean, it's just the way it is. Because 5% means that 5% of the time you're going to be wrong. So I'm just saying that's the deal. Okay, getting back to here. So we've got our alpha. Now for the fun part. Determine which distribution. We're going to be using the t distribution. But that's going to be easy because you just pick the right, it's going to be fun. It'll be given to you. You're not going to have to make that decision. Okay, now for the fun, and that is we get to use Excel to compute the test statistic. Thank God for Excel. Take a look at the garbage that we have to deal with here. That's the test statistic. T is equal to this. Now, let me just point out before we go on, it looks crazy, but this actually is somewhat familiar. You have the observation minus the mean. Okay, I know, they're different, but you have the observation minus the hypothesis divided by the standard deviation. You recognize that? It's a z-score. It's the same form. It's the same thing as a z-score. So we've got that, but things get ugly when we start computing that standard deviation down there. It's called the standard error, by the way, but whatever. Here's what it looks like. So the population, and you get a different version if the population standard deviations are assumed to be equal or unequal. We'll talk about that in a bit. I think Newton talks about the population variance instead of, it's essentially the same. If the population variances are assumed to be equal, you would use this formula. I know. it gets kind of, yeah, it's kind of like it gets worse and worse as you go down the list. And then so we'll let Excel deal with that. And then degrees of freedom, which whenever you're using a T distribution, you need to know the degrees of freedom. So there you go. There's the degrees of freedom. Now, if the population variances, I'll use that language just so that you don't get, I'll show you this on Newton before we leave. Variances are assumed to be unequal, then you use this as your, so that's not quite as ugly. And then the degrees of freedom are different. So you can see it's a real lot to sort out. And can you imagine being a student 20 years ago with a hand calculator, being told, this is going to be on the exam. I used to have this on my exams, and students would be like, okay, here we go. So I'm thankful because there's not a lot of use in memorizing this if you're not a mathematician or a statistician. So we're thankful for Excel. So let's use Excel, and we're going to put all of this stuff into Excel. Oh, also, I should mention, I discovered something last semester I think is true. And so, so before we start coding this, I believe that the way that the method that Newton uses, that they use this for both of these end up being very similar numbers, but technically statisticians will say you use this if the variances are unequal, or no, are equal. Use this one if the variances are unequal. So you have two formulas, but I believe that Newton uses this one exclusively. So just wanted to warn you about that when we get to there, we'll just use that bottom one. Okay, so we're getting back to, here we go. Okay, here's our stuff. Here's Excel, and hopefully you have your hypothesis test gold that you worked on last week on Wednesday while I was here, and on Friday when I was just like, try? No one complained, or no one has been in my office the past 2 days. So I'm assuming everything went well. And also, Newton, you're doing your homework, so hopefully it's okay. So anyway, you've got these two. You've got the one mean and the one proportion. We're going to be adding 2 sheets to this, but don't get too excited. Just add one for now. So I'm going to click down here, the little plus sign. What in the world? Why is it there? I want to move it over. Can I move it? Oh, yeah. Okay. So I just want it to be at the very end. So at the bottom, I've got a new one. I'm going to call this one 2 means. Which one do we do first? Just a minute. Let me see what I did in the past. See, I've got my cheat sheet up here. Sorry. Yeah, 2 means same variance. That's what I did. Okay, so 2. Oh, it never got renamed. Let me try again. Rename. I'm going to name this, and you can't see it. It's so small. So this is 2 means. Oh, can I put a comma? Sure. Same variance. So I just have 2 means, same variance. So here's the deal with the whole same variance versus different variance. When we look at this situation, we have these 2 exams that I gave. And depending on whether or not the 2 exams have the same variance or different variances, it affects how you put your hypothesis test together. It's just a subtle difference, but statisticians are very picky about how things work. So we're going to assume, at least for this one, that the 2 means have the same standard deviation, the same variance. So we'll start with that. Okay, so bear with me. You probably know where this is heading. Wait, where is this? Where's my thing? Is that it? Oh yeah, there it is. Okay, so we'll get started. The first bit is not going to be very shocking. It's the same as it always is. We need the information from the sample. And so, hold on a minute. I need to set this up so I can see it on both screens. Okay. Okay, I can see it. I am so happy. Okay, so I know I've got sort of a split screen thing going up there, but that's as big as I can make the cells. I guess I could shove this over a bit. There's going to be a time when we want to be able to see stuff behind. Well, here, we'll just do this. Okay, so we have x bar 1, x bar, wow, caps. I didn't mean to do caps. Let me get rid of that and do it in lowercase. X bar 1. This is the sample mean from sample 1. And then you have X bar 2. So sample mean from sample 2. You have S sub 1, that's the sample standard deviation from sample 1, and S sub 2 is the sample standard deviation from sample 2. We have in 1, I think you probably know what that is, number of in the sample 1 and in 2. That's sample 2, and then you have the null hypothesis. Okay, so that's all the stuff that you would ever change. So I know that's a lot of stuff, but each time you tackle a new problem, you're going to go and change these. You probably won't change this. I'll explain why in a bit, but these are the ones that you're going to be changing up here, these top 6, to match what we have. So let's go over to our data and compute these numbers. Let's see, that's this. That's why I wanted to be able to see both. Okay, so here, I know what I'll do. I'll just copy these names over here, paste them in here, and then I'll just do this, equals average. I'm lazy, so I'll do A:A. You can actually highlight the data instead of, but I know there's nothing underneath that data other than blank cells. So that'll just average together just the data. And then down below this, I'll do equals standard deviation, STDEV dot S, open parentheses, A:A again, because I'm lazy. Maybe I should actually label these. This is the mean. This is the standard deviation. And this is going to be in. So there it is. So let's do the in is going to equal the count, A:A again, because I'm lazy. So there were 11 of you. And then I'm just going to copy this over to there. Same formulas, but it's for column B, just so you know. I'll pause because I know I did that quickly and see if there are any questions or concerns, or if you're like, oh, my number is different from yours, we can fix it. Hopefully we can get the same numbers. So take a minute, get your mean, standard deviation, and the sample size. Ooh. My son-in-law did Wordle in 5. Oh, let me see. Sorry, I could actually put it up on the screen. Oh, now I'm going to have to send him my Wordle. I normally don't, but if I get a text like this, I'll respond in kind. So very nice there. Let me turn off my ringer. Okay. There's got to, yeah, I'm sure I'll have to look up some Wordle statistics and use them next time. So. Yeah, it must be. And actually, my son-in-law, it's not his first language either. So there you go. Although he got it in 5. But you're better than someone who speaks French. So apparently Spanish is better than French. Yeah, I would agree. I'm trying to learn French, and it's like, why? Why do you speak that way? Okay. Okay, well, anyway, let's see if we can do this. So anyone complaining? No one's complaining. Okay, I don't want to have to type all this. So I'll show you a little trick when you copy. So I'm going to copy these. If I just paste them over here, where is my hypothesis test gold? If I just, they're in the wrong order. I guess I should have made them in the same order. Oh, well, I guess I'll just be typing them. I was trying to avoid that. Okay, just a minute. Maybe if I put this, I don't know what to do now. Here. Okay, here, I'll do this, and then I'll do this. There we go. Now I can see sort of, there we go. Now I can see them. Okay, I'll just do it. Yeah, I probably should have put these in a different order. They're in the order that I have them in from last semester. I thought, well, I'll just do the same thing I did last semester, but okay, so we've got 89. If you copy and paste, you'll copy the formulas instead of the numbers. It's possible to avoid that, but I'm not going to bother doing that now. By paste special, let's see, S1 is 8 points. So the one on the left is sample 1. So let's see, 49. And then this is 12.8811. If you have more digits than me, that's fine. There we go. So you should have those numbers. So even if you didn't, well, hopefully you can compute those. No one's yelling. You know the drill. If you get stuck, it's so much better if you stop me when you get stuck. Hayden. That is right, because if you type mean into Excel, it'll say, I don't know what you're talking about. Oh, you got a different number for which one of these? Yeah, average. Average. I don't know. You can look that up later. Google it. Okay, so next, we need to know what the null hypothesis is. Notice H sub 0. So here's how you determine the null hypothesis, is we go over here to our null hypothesis, and you see that the null hypothesis is that mu1 is equal to mu2. Watch this algebra. Take this and move mu2 to the other side. And notice that mu1 minus mu2 equals 0. So for this class, the null hypothesis will pretty much always be 0 when you're doing this sort of a test. However, there will be situations in your advanced psychology research methods or whatever where you're interested in whether or not the difference between two averages is bigger than a certain amount, like larger than 10 or whatever. So in that case, your null hypothesis might be 10 or 5, but for us, the difference will always be 0. So really, whoops, not that one, this one, really this null hypothesis will always be 0. So maybe I'll just highlight that one yellow, just for fun here. That one will be yellow, and then these are all green. Those are the ones you want to mess with. And at least for now, don't mess with that null hypothesis, because that one is always, at least for us, going to be 0. In the future, if you take another research methods class, you might have something different. Okay, let's see. Can I get everything up that I need for this? I don't think so. Yeah, it's too much. Here, I'll just blink it up on the screen so you can see the horrors that we're going to have to deal with. Okay, so here. Let's just get that off of there because that's ugly. Okay, so we'll do our best to have this. Give me a sec here. Okay, so this first one, okay, so maybe I should, whoa, I clicked the wrong thing. Give me a sec. Okay, there we go. Sorry, I have two screens. I can see that on this screen and a portion of this screen. It's confusing. Okay, so here's how this is going to work. We need to, whoops. There we go. We need to have some things. We're going to call this the standard error. This is that standard deviation. Oh, turned green. I don't want it to be green. I want it to be yellow. Let's see. I'll just highlight this yellow. There we go. Okay, so we have the standard error. We have the t statistic. Green. I don't know why it's changing. I'll fix it later. You're going to have the degrees of freedom. Then we're going to do the p-values. And you know the drill. The p-value is going to come in 3 flavors. You have the left-tailed, you have the right-tailed, and you have the two-tailed versions. So we'll deal with all of these momentarily. Let me just turn these all yellow because I don't like that they turned green. I probably should have waited till the end to highlight. But there it is. So standard error. So this is going to be the ugly formula. So this is going to be the square root. Let's see, can I see everything? Sure. Okay, so I'll do it, and then I'll let you see it. Don't worry. Let's see, can I move this over? There we go. Okay, so this is going to equal the square root of the first, let's see, the first standard deviation squared over the first sample size plus the second standard deviation squared over the second sample size. So this is the simpler of the two standard deviation formulas that are on this thing. And like I said, I think last semester there was a big kerfuffle when people were doing this particular assignment, and I just have bad memories of it. And I think that this is the deal, is that we use this formula for both. We'll find out. Maybe we should even, well, if we have time, we'll take a look at Newton and we'll try one. Okay, so there's that. You should get 4.32. I'll put that back up there again. It should be 4.32 though. I'm getting nervous. 4.32 is pretty darn small. Well, let's see. Okay, so the test statistic. This is going to equal, and this is the formulas on the PowerPoint, but I've got it memorized. So it's going to equal in. Oh yeah. This one. Okay, yeah. It's better now than waiting. Oh yeah. Oh, sorry, August. You could if you want to. It's not going to make a difference, I don't think. Here, let's just check. It'll be fun. So it's 4.32. So yeah, I'm a big fan though of parentheses. The more, the better. So let's just see if this changes. I don't think it'll change anything. Yeah, it's still 4.32. So there you go. Yeah, so if you get a number different from me and you have exactly the same formula, you better check to see if you've typed in your stuff that's green correct. That might be an issue. Well, Elizabeth, did you get it? You think so? Is it 4.32? No, I have other somewhere else. You're just going to give up for now? Okay. Well, if you still have trouble later, you can always pop by and we'll fix it. Okay, test statistic. So the test statistic, this is the observation. The observation, here I do need a double set of parentheses. The observation is the difference in the means. And we're going to do, which way is it? It's, which way am I going to go with this? This is going to be a problem. Hold on a minute. I want to make sure I get this right. Here, I'll show you what I'm dealing with here. Here we go. Show you this and this. Okay, so here's the problem. Yeah, I think, let me see. I guess I could always see what I did last semester. Oops, escape. B1, B2. Interesting. Okay, I'll just do what I did last semester, and then we'll deal with any repercussions afterwards. Okay, so let's see how this works. So we're going to do this equals double set of parentheses, and then you're going to do the difference in the samples. So this is your sample data, if you will, and then subtract off the null hypothesis. Close those parentheses and then divide by the standard error. So there's what the formula looks like. Let me just get the number just briefly. It's okay, I'm feeling better about this. 1.73. But that's what it is. So this is just your standard z-score. You're using the stuff that your data minus what you assume is true for the population divided by the standard deviation. That's all it is. I'll give you a minute in case you need some help. Well, why then if yours is wrong, then you don't have the same thing. Okay. Let me come look. It's fine. This is better to check. What is this thing? What? How is it so big? I don't know. Okay. This thing squared. Oh, yeah, you've got the wrong numbers. Look at your S1 and look at my S1. Yeah, see? Yeah, S1 is 8.05. Yeah, so yeah, you've got the right formula, just the wrong numbers. Yes. And do you have all the correct numbers up here? They're all exactly the same. And is your formula, I'm coming back. I'm gonna, wait, where's my formula? There it is. There. Check your formula. I'm coming. All right, what do you got? Let's see. That thing squared divided by that thing plus that thing squared divided by that thing. Let's see it. Why? Double click it. What are you doing?
I'm bringing this over so you can.
You've got another problem?
No, so you can use the formula. Mine just has more decimals.
No, yeah. What in the world? Why? Oh, you've got times 2 instead of squaring. Yeah, okay. Phew. Sorry, my eyesight's not as good as it used to be. You've got a problem? What in the world? What is this? Oh, wait, what's wrong? Oh, you don't have the right set of parentheses. Put another parenthesis after B39. Okay, and then get rid of the parenthesis at the end. Hit enter. That's closer. I don't know, there may be another problem. All right, you guys will figure it out. Here, let me go click. 1.73. Okay, sorry. Yeah, there's an exponent. Yeah, make sure it's identical and don't trick me with your thing. Okay, so let's see. So Will, you can double check this and also and I saw you're doing something weird with yours. I can't help you. No, I'm just kidding, Will. Seriously though, if you because you're choosing to do it like he's got his like down at line 40 or something, which is fine, I guess. It just seems a little weird. But anyway, yeah, so let's deal with degrees of freedom next. Here we go. It's taking longer than I thought it would, but that's okay. Okay, so this isn't too bad. Whoops, I keep clicking the wrong thing because 2 screens. Okay, there, that's better. Degrees of freedom, this is just going to be the number in sample 1 plus the number in sample 2 minus 2. So think of it this way, that when you're doing a degrees of freedom, normally you would do the number in your sample minus 1, but I have 2 samples now, so I do the number in sample 1 minus 1, and then the number in sample 2 minus 1, and that gives me minus 2. So it's not that confusing, I guess. And thankfully, because of the way Newton does it, that's as difficult as it gets. Okay, we're almost there. Hit that. You should get 22. I'm just double checking my math here. Okay. All right, now the p-values. This we've done. You could almost just copy this directly from your hypothesis test for one sample, one mean, but let's retype it. This is going to be t dot dist, open parenthesis, and we're going to throw this in there, that t-stat, and then it says degrees of freedom. Sure, we'll just do that. And we're going to type true because we truly want the answer. And that's going to be the left-tailed test p-value. It's 0.95. If you get that one correct, you'll get the next one correct. Actually, you'll get all 3 of them, hopefully. So that's the first one. The right one is always just equal to 1 minus the left one. I know I'm going quick. I'll go back. Why don't I just go back now? So here's the left one. It's the t distribution using that test statistic in the degrees of freedom. And then the right-tailed p-value is just 1 minus the left-tailed p-value. All right, I sense. Did you ever sort out your numbers back here, Elizabeth? Yeah. Oh, you got them, and so you can.
It was so I missed S1, okay. So all of them were like.
Oh yeah, it's like a snowball. Okay, yeah, get that p-value in there. thankfully, once we finish this, the next one is actually pretty quick because there's minor changes that we need to do. Okay, while I'm waiting, I'm going to find my Newton. Let's see, find Newton. Manage. Where is this? To mean with Excel. Okay. All right, I've got my Newton for future use. There, I'll put it. Okay, so the right is just 1 minus the left. So here this. So 1 minus the previous one. Okay, everyone's got left and right? And Hayden, you're helping the back row. Thank you. Okay, so if we've got our left and our right, then the final one is the two-tailed. The two-tailed is pretty straightforward because what we're going to do is we'll do equals 2 for two-tails times the minimum of the right-tailed and the left-tailed. So you'll get 0.97. So, but there it is. So you'll have 0.95, 0.49, and whatever the next 0.9 something or other. So here it is. Yeah, 0.097. So there's your 3 p-values. And once we get all our numbers working, then you're going to be golden. You're going to, it's like so gold. Yeah. You'll be able to do the rest of this. In fact, I'm just going to jot down. This is a two-tailed, the thing we were doing two-tailed. So I'm going to jot down this p-value. P-value, so give me a sec. .0976, whatever. Okay, so I've got my p-value. So let's just show you, let's finish up this particular hypothesis test. So we've got the p-value, and so since the p-value is greater than alpha, let's see, we'll change colors. So the p-value is greater than alpha, and so you fail to reject. And remember, don't just say that. If you leave it with, if you don't leave me hanging, tell me what you're rejecting or tell me what you're failing to reject. So I'm failing to reject the null hypothesis because the p-value is greater than alpha. And so my conclusion is that there is not enough evidence to suggest, what are we suggesting? We're suggesting the alternative hypothesis. Here's the alternative, and this is always going to feel weird when you have something like this because it'll feel like you're doing a double negative, but it's just the way it is. So there's not enough evidence to suggest that. How do I say that in English? I would say that the average for test 1 is different from the average for test 2. That the average score, look at this, I don't even like to write, for exam, whatever, it was the plus, wasn't it, is different from the average score for exam times. Whew. That was rough. And bear in mind, I know that you're looking at this thing, you might be thinking, wait a minute, didn't we do this and we know what the averages are? Well, we know what the averages are for the people who took each copy of the exam. We don't know how the people who took exam plus would do if they took exam times and vice versa. So that's what this is saying is, for if we gave these exams to everyone, would it be the case that one of them would be different from the other? That's all we're saying. So there's not enough evidence, but it's actually, I was a little bit scared because that p-value is pretty low. So the difference is, it's a little scary, but it's all right. Let's take a peek at, let's see if this is the case. So here's a Newton problem. And if this is the type that we can use this spreadsheet for, we'll do it. If not, we'll have to wait. So here's the way you're going to determine which of the two spreadsheets, and we have 10 minutes, but the second one isn't going to take long, is you look through. I know there's a lot of words here to read, but here is the thing that you're going to be looking for. You see this phrase? Let me highlight it. Assume that this will be part of every stem of, the stem of every problem will have some statement like this. So look for that. It says, assume that the population variances are not equal. So unfortunately, we're going to have to delay doing this until we fix the spreadsheet because we have the one where they're equal. So if it says that they're equal, you'll use the spreadsheet that we just made or the worksheet. If it says they're unequal, you're going to use the next one, which we're going to make right now. If this one works, then you're not going to have much trouble making the next one. Yes, Hayden. Hold on a minute. Yeah, I remember this. What was the deal? No, I'm doing this a little differently. I'm doing it differently. Yeah, no, this should work no matter what. Yeah, so it should work. Yeah, I think I fixed it. Yeah, there was a little issue with that. You're right. But no, don't worry. Okay, so here's what I want you to do. And this is a little here. I'll zoom in even though it's going to be pixelated so you can see this down at the bottom. So down at the bottom where the tabs are, I have my two means, same variance. I right click this, or if you're using a Macintosh, you'll just have to, whatever, double touch, quadruple swipe. I don't know what you do. But anyway, you do this so that you get this context menu and then go up here to move or copy. See, move or copy. If you click that, move or copy, then it gives you the option to move or copy. And I'm going to click move to end and then create a copy. So basically, I'm just going to make a copy of the previous one. So if you don't click create a copy, nothing will happen. So you want to move it to the end, like put a new one at the end, and this will magically appear here. Then click OK. And then you should have two. Notice down at the bottom, I actually have two of them, and they're the same, except for this one has a little number 2 in it. So when you get that done, then just rename this second one. So I'm just going to rename this. Let's see, rename. And I'm going to call it 2 means. Let's get rid of the 2. And instead of same, it's different. Different variances. So that's the first thing that you need to do. Create a new spreadsheet. And we're going to, I'm glad that this one came up because I want to make sure that I've got all my formulas right back here on Newton. Okay, so the only other thing that you need to change once you have a second, so notice I've got my first one is over here, my second one, currently they are identical. Now we're going to go and make the change that we need to. Let me unzoom. There we go. So the only difference, I'm pretty sure this is the case, I guess we're going to find out. The only difference that I remember from last semester, because this was a slight problem, and if it still is a problem, just send me, well, yeah, I guess I'll be getting 30 emails, but send me an email and then I'll make a little video tomorrow or whatever with the correction. If this is, yeah, so I just have a memory. That's what I did last semester. It's like everyone bombarded me with emails and it's like, oh, it's not working. And I said, okay, I'll fix it. Okay, so the difference is the degrees of freedom. So this is on the 2 means different variances. You have equals. Instead of degrees of freedom, what we had, we're going to do the minimum. So what you do is equals the minimum of the 2 sample sizes. So then I go up here to the first sample size, and then I do the second sample size. So that'll tell me the minimum. Of course, we can see it's 11, but we want to automate this, and then subtract 1 from that. So that's the only difference, I'm pretty sure. So that at least that seemed to be what worked last semester. So then I've got 10. You notice the numbers change a little bit down there. So let's find out if this is indeed the case. So, oh, here, let me make sure. I know some of you weren't following. Here you go. There it is, the degrees of freedom. This is on the second version. Leave it alone for the first one. Okay, so let's pull this over. Let's see if we can see everything. Let's see, can I see everything? Okay, I'm gonna have to mess with this. Pull this over. Ah, that's beautiful. Okay, so it says Claire said okay, so in 1 and in 2, notice that the sample size of 30 from each group. I don't even know what Claire's doing, but I don't really care. I just want the numbers. So we have 30 people from each group, blah, blah, blah. Two mean, okay, alpha is 0.1. That's good to know. Oh, we need the, okay, I'm just going to blow through this. I know you're going to be jealous. Whoops, where'd it go? It's over here. Why is it so small? Here we go. Okay, so I have the instructor cheat. There you go. Okay, whatever. Hold on a sec. I want to get to the part where we're doing numbers. Oh, yeah, okay. So here's a situation where they give you the data and they want you to compute things. So copy this to the clipboard. Go find a spreadsheet somewhere where you can type this stuff in. Is this, ooh, that's so little. I didn't want to do it on my main spreadsheet, so I'm going to pull this over. So let's just do this here. Oh, no, can I do this? Oh, let's see. Can I just paste it in here? Oh, fascinating. Look at that. Okay, I got my numbers. Yeah, that's great. Okay, I'm so happy. So anyway, I just computed the mean and the standard deviation of all of these things. And you got the count there. Okay, so now I can go back here and change my numbers. Give me a sec. So let's see. So you don't have the data because you're not doing the same. So I've got, yeah, plus and times is whatever, sample 1, sample 2, 98.2333. So you could change this on yours to see if yours works. 0.4352 and 12.358, oops, 87. Okay, so there it is. So there's the rest of this is all set up correctly. So these are the numbers that you should end up with if I've got everything ready. Okay, so let's go back to Newton and see how things go. Okay, so blah, blah, blah. Oh, test statistic. Let's see if I get it right. Okay, so the test statistic, how many digits? 2 decimal places, p-value to 3. So negative 1.84. And then p-value, is this a one-tailed, two-tailed? What are we doing here? Okay, it's a two-tailed test. Notice that the alternative hypothesis, since I didn't bother thinking about it, alternative hypothesis is a two-tailed. So I'm going to use the two-tailed, 0.075. There's 3 digits. So it seems to change depending on the problem. Just be aware. Let's submit this and see if I'm right. It's not right. Hold on a minute. Okay, so, oh no, this is good. This is much better. This is better for me to know that there's a problem now rather than have you suffering. So let's see where did it go? Where did my answer go? Oh, there it is. 7.2, interesting. Okay, so it doesn't like this. Hold on a minute. What if I use the other, just a minute, equals not in1, this plus this. Do I have these mixed up? No, that's different as well. Okay, I'm gonna have to look into this situation here. So you can't do your homework until I deal with this, and I'll let you know where my error is. I thought I had this fixed. Okay, so let's double check though the other one. So I've got a problem. It's probably something minor, but I'll fix it. So yeah, I have bad memories of this happening last semester. Anyway, let's just cheat this one. Oh, is it time to go? No, we got 1 minute. Okay, continue. Okay, well, here's what I'll do. I will send you, I will double check my files. I will find out what the problem is. I'll send you an email by tomorrow morning that will fix this. It's probably just something out of place. I'll let you know what it is, though, so that you can do the homework for Friday. All right, thanks for sticking around. If you want to stay and chat, you can.